Welcome to this Learn the Electrics Help and Tips video about the 18th edition Wiring Regulations exam. This is session number 4, and in this video we are looking at two very important formulas that almost always appear in the exam. The 18th edition exam tests your understanding of the regulations. You need to show that you know how to use the wiring regulations and the formulas that are used in the book. In this video, we will cover some essential calculations that you are required to understand and be able to answer questions on. Working through these practice calculations will improve your knowledge and understanding of this required part of the exam. We will cover the following equations and formulas, which often appear in the 18th edition exam. The first is the Adiabatic Equations, calculating the size of protective conductors to install and the time to reach the limiting temperature of the cable. Then there are the voltage drop formulas, how to calculate the actual voltage drop for a circuit and how to find the maximum length of a circuit. In the exam, you may get just one question or you may get all 4 versions. We can start with the Adiabatic equation for the size of protective conductor, the earth. You want the equation that starts with S equals, S for size. This is the equation. S equals the square root of I squared times T divided by K. Below the formula are the descriptions of what each letter means. In the exam, the question will give you the numbers to use or enough information to easily work it out. Remember, you only have 2 minutes per question, so they can't make it too hard for you. If you can find the correct formula, you can answer the question. In our example, we are asked to calculate the size or CSA of a protective conductor from the information given and to choose an appropriate answer. We are told that I or current is 500 amps, T or time is 0.4 seconds, and K is 115. Calculate the answer and make a choice from the 4 answers offered. Don't worry about how the numbers round up or round down. The correct answer will always be very obvious. The formula can be found on page 196 of the Wiring Regulations book. Here is the formula again. As we said, it begins with S for size. For this equation, start by working out the bit underneath the square root sign. We want to know what I squared times T is. Any number squared is simply that number multiplied by itself. So you can see here that 500 squared is 500 times 500. And then we multiply by 0.4. This gives us 100,000, or 1 with 5 zeros. Now for the square root part. The square root of 100,000 is 316.22 and lots more numbers, but we will just cut it off at the 2 decimal places. Now that we have this, we can divide it by K, or 115 in this case. So 316.22 divided by 115 is 2.74 square millimeters. Again, chop it off at 2 decimal places. That's the answer, 2.74. But what are we going to select from our 4 choices? The answer must be equal to or greater than 2.74, so that must be a 4mm cable. Choose answer B. OK, now it's your turn. With each question, pause the video, read the question, and then calculate and choose your answer. When you are ready, restart the video, and the answer along with how we worked it out are given. Question 1 asks us to calculate the size or CSA of a protective conductor from the information given and choose an appropriate answer. I is 420 amps, T is the time at 5 seconds, and K is 143. Again, there are 4 choices of answer. Pause the video, find your answer, and then restart the video to find the method and the correct answer. Don't worry at this stage about how long it takes you. Yes, you only have 2 minutes in the exam, but here, right now, it doesn't matter. What does matter is that you learn and understand what you are doing. And here is the method and the answer. We've shown the calculation again. I is 420 and T is 5 seconds. 420 times 420 times 5 is 882,000. And the square root of that number is 939.14. And 939.14 divided by 143 will give us 6.56 millimeters. This is above 6 millimeters, so we should choose the 10 square millimeter cable. Answer D. Now attempt question 2. We are asked to calculate the size of a protective conductor from the information given and to choose an answer where I is 1010 amps, T is 0.4 seconds and K is 115. Pause the video whilst you calculate your answer and make a choice. You should have 1010 times 1010 times 0.4 to give 408040. And the square root of 408040 is 638.78. Divide this by 115 and we have 5.55 millimeters. So the answer is C, 6 millimeter cable. And question 3 next. Using the information given, calculate the size of the protective conductor and choose an appropriate answer when I is 240 amps, T is 5 seconds and K is 115. Again, pause the video and do the calculation. And here is the solution to question 3. 240 times 240 times 5 is 288 and 3 zeros. The square root of this is 536.65. And 536.65 divided by 115 is 4.66 square millimeters. You should choose answer D, 6 millimeters. With a little bit of rearranging, we can use the Adiabatic equation to calculate how long a conductor or cable will take to reach its limiting temperature. This will be 70 degrees Celsius for standard PVC cable. We want to know if the cable will begin to melt and degrade before the circuit breaker trips. If the breaker operates in 0.4 seconds and the cable takes 0.5 seconds to reach this limiting temperature, then the cable will be okay. The power will be off before it becomes damaged. This is the formula, and below it the meaning of the symbols again. This equation begins with T for time. In our example, we want to calculate the time T for a protective conductor to reach this limiting temperature of 70 degrees centigrade. Given the following information, we must choose an appropriate answer. The given information is the CSA or size of the cable is 4 millimeters, I is 700 amps and K is 115. This formula is shown on page 92 of the wiring regulations. Looking at the working out, we have 115 times 115 times 4 times 4 to give us 211600, and 700 squared is 490000. Divide one by the other and we get 0.43 seconds. Our answer should be C, 0.43 seconds. If the circuit breaker operated in 0.4 seconds, this cable would just be safe. It would not quite have reached its limiting temperature. Try question 4 on your own. Calculate the time T for a protective conductor to reach its limiting temperature of 70 centigrade given the following information. The CSA or S is 2.5 millimeters, I is 600 amps and K is 115. Pause the video, do the calculation. You should have 115 times 115 times 2.5 times 2.5 to give 82656.25, and 600 times 600 gives 360000. Divide one by the other and we have 0.22, and we should choose answer A, 0.22 seconds. Clearly, if the circuit breaker operates in 0.4 seconds, this cable has reached its limiting temperature long before the breaker cuts the power, and the cable may now become heat damaged. Question 5 asks that we calculate the time for a protective conductor to reach the limiting temperature. Given the following information, choose an appropriate answer from those offered. The CSA is 6 mm, I is 1050 amps, and K is 143. Pause the video again. The answer to question 5 is 143 times 143 times 6 times 6, which is 736164, and 1050 times 1050 is 1102500. Dividing these out, we have 0.66 seconds, and we should choose answer C. Now, on to question 6. Calculate the time for a protective conductor to reach its limiting temperature given the following information. A CSA of 10 mm, a current I of 800 amps, and K of 115. Don't forget to pause the video. The answer this time is 115 times 115 times 10 times 10 to give 1322500, and 800 times 800 to give 640000. Divide one into the other and we have 2.06 seconds. Choose answer C. We can look at voltage drop now and begin with calculating the actual voltage drop in the cable. Before we calculate actual voltage drop, let's refresh ourselves on what the maximum permitted voltage drop is. You will find this on page 383 of the wiring regulations. For lighting circuits, the maximum voltage drop is 3% of 230 volts for a single phase circuit, or 6.9 volts. For all other non-lighting circuits, it is 5% of 230 volts, which is 11.5 volts. This is the formula that we shall use, and the symbol descriptions are below. When we calculate the actual volts drop, we should compare it to the maximum permitted. If it is below the maximum, then happy days. If it is above, then we must consider bigger cable, shorter routes, or some other solution. Begin by calculating the voltage drop in a heater circuit with a maximum load, or IB, of 13 amps and a circuit length of 30 meters. The circuit is wired in 2.5 mm twin and earth with an MVAM value of 18. Here is the formula shown again. Simply insert the numbers into the formula as shown. 18 times 13 times 30 is 7020, and divide this by 1000 to give 7.02 volts. The actual volts drop therefore is 7.02 volts. And the maximum permitted volts drop for non-lighting is 11.5 volts. The volts drop is within acceptable limits, so we should choose answer A. Have a go at question 7 yourself. This is such an easy calculation. Calculate the voltage drop in a lighting circuit with a maximum load IB of 6 amps and a circuit length of 45 meters. The circuit is wired in 1.5 by 1 mm twin and earth with an MVAM of 29. Pause the video, do the calculation, choose an answer. You should have 29 times 6 times 45, and then divide that answer by 1000 to give 7.83 volts. Choose answer D, 7.83 volts. The actual volts drop is 7.83 volts, and the maximum volts drop for lighting is 6.9 volts. Therefore, the actual volts drop is above acceptable limits. Question 8 now. Calculate the voltage drop in a cooker circuit with a maximum load IB of 30.96 amps and a circuit length of 40 meters. The circuit is wired in 6 by 2.5 twin and earth with an MVAM value of 7.3. Again, pause the video and choose your answer. 7.3 times 30.96 times 40 on the top row, divided by 1000 on the bottom row, and we have 9.04 volts. A cooker is clearly non-lighting, so the maximum permitted is 11.5 volts. The voltage drop is therefore acceptable, and our answer is D, 9.04 volts. Now question 9. What is the voltage drop in a 2 kilowatt water heater circuit with a maximum load, or IB, of 8.7 amps and a circuit length of 60 meters? The circuit is wired in 1.5 1mm twin and earth with an MVAM value of 29. Pause the video again. Our answer is found by 29 times 8.7 times 60 and dividing by 1000, and this comes to 15.13 volts. So we should choose answer A. Because the actual volts drop is 15.13 volts and the maximum permitted volts drop for non-lighting is 11.5 volts, the voltage drop is above acceptable limits. Now we can move on to a variation of the voltage drop formula and calculate the maximum length that a cable can be to not exceed the maximum permitted voltage drop. Here is the rearranged formula. Notice that now we use the maximum voltage drop in the calculation. In our case, this will be 6.9 volts for a lighting circuit and 11.5 volts for all other circuits. Begin with an example calculation. Calculate the maximum length of a shower circuit wired in 10mm twin and earth to not exceed the maximum permitted voltage drop of 11.5 volts. Take IB as 39.13 amps and MVAM as 4.4. Again, it is just a case of inserting our given numbers into the formula. 11.5 times 1000 is 11,500 on the top row. 4.4 times 39.13 is 172.17 on the bottom row. Divide one by the other as shown and we have 66.79. So we should choose answer C, 66 meters. And now try question 10. What is the maximum length of a radial socket circuit that is wired in 2.5mm twin and earth cable and protected by a 20 amp circuit breaker and an IB of 20 amps? Take MVAM to be 18 and max VD as 11.5 volts. Pause the video and calculate your answer. 11,500 on the top row, 18 times 20 or 360 on the bottom row. Our answer is 31.94 meters. Looking at the choices, we should select answer B, 31 meters. Now try question 11. What is the maximum length of a radial socket circuit wired in 4mm twin and earth cable and protected by a 32 amp circuit breaker with an expected IB of 32 amps? Take MVAM to be 11 and max VD as 11.5 volts. Pause the video, calculate the answer. 11.5 times 1000 or 11,500 on the top. 11 times 32, which is 352 on the bottom. And out pops the answer, 32.67 meters. From our answer choices, choose answer A, 32 meters. And finally, question number 12. What is the maximum length of a water heater circuit wired in 1.5 twin and earth cable with a stated IB of 8.7 amps? Take MVAM to be 29 and max VD as 11.5 volts. Pause the video. 11,500 on the top, 29 times 8.7 or 252.3 on the bottom. Our answer is 45.58 meters. From the choices offered, select B, 45.5 meters. The two formulas and the variants used in this video must be understood. You must be competent at using them. They are important not just in the exam but in working life too. The voltage drop formula can be used to find the actual volts drop in a circuit, and with a little rearranging, a new formula is found that will give us the maximum length of a circuit. The Adiabatic equation has two forms also: to calculate the time to reach a limiting temperature, and secondly, the size of the protective earth to be selected. Practice is the key to becoming proficient at these calculations, and we do hope that this video has been helpful in preparing you for the exam and that you've added a little more knowledge to your mental toolbox. Thank you for watching this video. It is very much appreciated. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. Here are some tips on getting even more information and help out of learnelectrics.com. At your web browser, enter learnelectrics.com into the search bar, select learnelectrics.com from the choices offered, and the website as shown will open up for you. You now have a couple of choices. You can search for a help item or any video by entering a keyword into the search bar on the right. Click on return and all the help files and videos with that word in the title will be listed for you. They will be shown with a short description, and each video listed will have a link shown that will take you directly to that exact YouTube video. Or you can browse through a list of all the available items and videos. To do this, click on the LE logo on the top left of the home page and all our items and videos will be shown. There will be 10 items shown on each page, and at the bottom of each page is a page selector, page 2, 3, 4 and so on, that will bring up the next 10 items or videos in the list. And don't forget that you can also type in Learn Electrics, all one word, into the YouTube search bar to go directly to our channel at any time from any computer. We are constantly adding new videos to our channel. Don't miss the next one. Once again, thanks for watching, and we hope to see you again very soon.